Hello, everyone. We're going to talk about machine learning. My goal today is to show you what we all can do with machine learning, whatever our background is, okay? But first, let's get introduced a little bit. So I'm Laurent Picard. As you can hear, I'm French. I live in Paris. I work for Google. I joined them less than 2 years ago. And in a previous life, I co-founded a company called Bookin, and I was a pioneer in the ebook industry. I made the first ebook device back in 1999. So I've worked 17 years in ebooks. But let me know a bit about you. Who is a developer in the audience? Yeah. I invite you to try to talk, because it's really a feeling to be in a room with so many fellow developers. It's great. Are there any data scientists or machine learning experts in the room? I'm not. Yeah, OK. So if I say something wrong, nobody will correct me, right? Are there already machine learning users? OK. So I hope everybody will learn something. And cloud users? OK, cool. I'll start with this quote from Arthur C. Clarke, because that's the feeling I had when I first saw some machine learning solutions. It felt like magic. But if you think about it, magic very often is just very advanced technologies, right? And that's what I want to show you today. But first, a question. What is a conference? That's human learning, right? What you're going to have the whole day is slides, right? And at the end of the day, you will have information from that. Well, machine learning is exactly the same. You have data. So I won't tell you what it is, but this is something I'm working on right now. This is data. And from this data, you want information and something useful, right? So how does it work? First of all, the experts have been trying to mimic the way we think our brain works. We're not sure about it, but that's how it started with AI, and then machine learning and deep learning. How does it work? We are using many examples, okay, to build a neural network. And as a result, we manage to solve problems. We don't know how it works exactly, but it works. That's the magic, okay? So to illustrate that, the way it works, there's a first part called training. You provide samples. So for instance, if we want to detect cats and dogs, we're going to provide many samples. It's going to build the neural network, change some coefficients in the layers, and then what we have to say is just, OK, here is the output that I am expecting. So this is deep learning. I will say machine learning in general, because it's easier to say, OK? And when you want to use, after the training, your neural network, you provide new inputs, right? Not the same ones. And then you will know the likelihood that it's a dog or a cat, OK? So we think it works like that in our brains, but we're not sure. Now, just to give you an idea, at Google, how much machine learning is important. So we've seen exponential use over the last years, and it's just the beginning, okay? So I guess you've used some features in many different solutions already, but more are coming. To give you the big picture, the way we see it today, there are 3 ways all of us can benefit from machine learning. If you're an expert, then you do hardcore machine learning. Some of them have been doing that for decades. I've talked to people who have been doing AI for 30 years. So they provided much of the theory, the algorithms, the experience that is working today with big computing power. For developers like us, there's something very easy to use. That's machine learning APIs. They're ready to use. You don't have to do anything. And in less than a day, you can actually build a solution with machine learning integrated. And this year, for less than 1 year now, there's a new solution in between that is filling a gap, because the machine learning experts, machine learning experts, they are quite rare, right? There will be more and more, but never enough. So right now, there's a new technique called AutoML, where you can actually use an existing model, but customize it with your data. And what we're going to see today are the first two ones with many examples, okay? Let's get started. So the building blocks, the machine learning APIs that we can all use today. They are really like Lego bricks, right? You can assemble them the way you want and integrate them into your solution. So they're ready to use. They've been trained on millions of samples. And there are 6 of them today. And they cover pretty much everything, all the different medias, text, pictures, videos, speech. And as an output, what you get is either information or this data transformed in another medium, like translated text or speech, which is another kind of information. Okay. Let's start with my favorite one, the Vision API. So why is it my favorite one? Because a long time ago, when I started learning how to develop, we learned how to work on pictures. And it started to work, but we never were able to really detect what was in any picture. And machine learning is the solution to do that. With a Vision API, you can do a lot of things. I'm going to show you some examples. For instance, you can throw in a PDF or a picture, and it will give you all the text that is found in the different pages. Of course, a PDF, a scan, a picture, I mean, not a raw text. So a few examples. I told you I'm based in Paris. So if I input a picture of Paris, then it will tell me, oh, by the way, this is a REST API. So you do a web request, and you get a JSON stream back as a response. Here is the response I get. It's telling me, OK, this is Paris. Here is the GPS location. And here is an ID to define Paris. That's correct. But anyone here could tell it's Paris, right? So I took a different picture with an Eiffel Tower, but it's not in Paris, it's in Las Vegas. The Vision API still works here. It's telling me, OK, this is the Paris Hotel and Casino, where they built a small Paris over there. And it even tells me where the picture is coming from and the picture that look alike. OK? So as developers, we always try to see the limits, you know. So I took a different picture. I cropped it. I skewed it, flipped it, so that someone like me could be fooled. If I don't look more than 2 seconds on this picture, I will tell, yeah, this is Paris. But this is still the Eiffel Tower in Las Vegas. And the Vision API is not fooled, because it's consistent. It always works the same. So I thought about it. How come? How come? There are 2 things. The text here, there's nothing on the Eiffel Tower, but more important, there's nothing below the Eiffel Tower. And this is something that the machine learning model caught, of course. OK? So now I'm going to use Tolkien examples. So back into literature. And this is a picture from New Zealand, where the movies, you know, Lord of the Rings were shot. And the Vision API tells me, OK, this picture is about nature. There's a tree, there are plants, there's a sky. So I can know what it is in the picture. But also, it's going to tell me that there's a sign over here with English text, right? And it gives me exactly what it has found. So you don't see well here, but the text is pretty hard to read, especially for a machine. It's like an Elfish. It's not Elfish, because we couldn't read Elfish. But there are some stresses on the vowels, right? So it's pretty hard to read. But it could get the text. The only mistakes it has done is that there's a space missing between except and on. So I guess we're still better at deciphering it here. So I wouldn't make the mistake. But it's still just a matter of time before the machine learning model learns that and does it better. Okay. Now I took a rendition of Gollum, and the Vision API is able to tell me that there's a face, able to give me the location of the eyes, the ears, the nose, and everything, and also the emotion. So it's telling me, okay, the face is likely to be angry. And that's correct. Gollum is most of the time angry. Okay. Here are the other emotions. So joy, sorrow, anger, surprise. And of course, every time I get the confidence. So if the model is not sure, I will get a low ratio. Okay, so can be handful. We'll try that with you in some moment. Then it's able to tell me, okay, what are the objects in a picture, but also what are the entities. So this time I took a picture from a Spanish newspaper, very rare picture about Tolkien, and the API could tell me that this is about Tolkien, right? And it also told me where the picture is coming from. And it's able to give me also pictures that are visually similar. So I check that, and what I get is actually a human being in a forest or against a tree. So it can be also handful to find something that is related to your data. So I told you it's a REST API, so that's something as a web developer that you can call, but as any developer, you can also use your favorite language. So on GitHub, we provide client libraries. So here, the example is in Python. But there are 7 different languages. I guess you all know at least one of them. And the way to use that is pretty easy. You create a client, you provide the content, and you call the feature, the function that you want. Here it's face detection, and then you can use the results immediately. So in a few lines, you can get the insight out of your data. Okay, so let's try something. So I took a picture. So far, I've shown you pictures that I've selected and so on. So now back to real live inputs. So I took a picture when I arrived yesterday. Okay, it's this one. And so you can try all the APIs that you see here. You can try them in your browser. You will get the links at the end if you want to check how it works. And it's telling me, yeah, that this is Hamburg Rathaus. Is it right? Rathaus? Yeah. Okay, good. And there are actually 2 locations: Hamburg Rathaus and sorry, my German is rusty. Hallsterarkaden. Yeah, is it correct too? Cool. And the label. So this is a waterway, there's a body of water, a canal, a town, city, and so on. So everything is correct. And the web entities, so now I know, yeah, this is the Hamburg City Hall. Okay, I didn't know. Now I can know exactly what it is about. So it works. But now let's try with your own inputs, okay? So I made this little demo. Let me explain what I did. So it's a very small demo in a few lines, but it can show you how it works. So what I did, I took, like Lego bricks, you know, I created in the cloud some buckets. So buckets are folders in the cloud. I created a few functions, 3 functions, that the functions are triggered whenever there's a new file in the bucket, okay? And what I did is also a small Python backend here. And the way it works, you're going to upload pictures if you want. You don't have to. Pictures might be seen on the display, okay? So if you're not supposed to be here, maybe don't take the picture. So you're going to upload pictures. The picture will call a function that will call the Vision API. The result will be stored here, which will call another function when I will do some picture composition with the information I have. And then it will store the result here, so a new picture. And this new picture will trigger a last function, which will crop the face in the picture, the largest face. So if you take a picture, there are 3 of you, the largest face will show up, okay? And this demo is called Stash Club. So maybe it reminds you of an old movie with Brad Pitt. Maybe it was here a long time ago. There are 8 rules for Fight Club, but for Stash Club, there's only 1. If it's your first time at Stash Club, you must get your stash, okay? Your mustache, okay? Let's get it started. So by the way, here are the cloud buckets. So they're supposed to be empty, yeah. So did you get your smartphones? Yeah. So here is what you can do: either flash the QR code or enter this URL bit.ly/demo CTH. CT for Code Talks, H for Hamburg. CTH, demo CTH. Yeah? Is it? Are you on a front page? Yeah, so you should be on something like that. Yeah, is it correct? So the URL is here if you didn't manage to do it. So let's start on my side. Okay. So the first thing is it's going to ask you for a nickname, and then it will ask you whether you're okay to use the camera. So let's try to be, I don't know, any emotion, surprise. So it's going into the pipeline, and you will get the result on your screen. Yeah. So I'm adding a mustache. I have the information, the mouth, the nose. I look like my father right here. He has a big mustache. Let's try something else, because I am also detecting emotions, right? So I went back, so feel free to do that a few times. Let's try to be sad. Oh, okay, that's not what I wanted to do. Okay. It's hard to be sad. I'm not sad. I don't know what I... Yeah, that's weird. And let's finish in beauty. Let's try to be happy. Hey. Okay. Yeah, mustache is a bit weird. So let's see what we have. Who's been angry in the audience? Hey, 1. Yeah, cool. Who's been sad? Hey, 1. Yeah, you're sad. Who's been surprised? I should have been surprised. Yeah, okay, a few of us. And who's been happy? Yeah, most of us. So a few ones coming. Okay. And I have a last category when it didn't work. Yeah. So, well, I put the threshold quite. Yeah. Yeah. When it's not likely but only possible, I didn't, because sometimes there are 2 emotions we're not sure about it. Okay. So you see, it's very, very easy to do, and it's fun too. Okay, let's go on. So you've seen you can get a lot of insight about pictures, but you can do the same with video, okay? So that's the Video Intelligence API. And basically, you can do pretty much the same as pictures, but you have the time dimension additionally. And so what you can do is extract the sequences. Let me show you an example. Yeah. So here, this is a video that has been indexed by the Video Intelligence API. And for instance, here I have all the different labels. So at the beginning, there's a spiral galaxy.
The world is made with tiny bits.
Yeah, that's correct. There are humans. Yeah, let's try at the end. Humans. There's a polar bear here.
You will fix something.
Yeah, so you see, like pictures, but with videos, you can now know the different sequences. So you can index pictures, you can index videos. Okay. So I'll try to go fast because there's a lot to cover. Now let's go to text. With text, you can get a lot of different insights. You can extract a lot of information. So I took a sentence from Wikipedia about Tolkien. Okay, Tolkien was a British writer and so on. So first of all, the natural language API tells me, okay, it's English. Okay, no big deal. But it's able to tell me the syntax, exactly how the text is built. So I get all the different relationships. That's something maybe at school it was kind of hard to do sometimes. And one thing I like as a developer is that I can get the lemmas. So here, for instance, was, it's telling me, okay, this is to be. And likewise, it can work with the nouns and everything. So it means as a developer, I can work in a canonical way. Exactly like when there was a picture with Tolkien, I have an ID for Tolkien. This is something unique that I can use. Okay. So now let's use the same sentence, but let's try to recognize entities. And the API is telling me that there are 3 different groups. The first one in red are persons, so Tolkien is a person, indeed. And again, I'm getting the same ID that when I was giving a picture of Tolkien. So it means I can work with different medias. I'll also get the Wikipedia page of Tolkien. The second group is only the green one, British, related to the United Kingdom, so it's telling me its location. Yeah. And the 3 books at the end are recognized as works of art, which is true, and an ID for each of them. So I can know how the text is built, and I know what it is talking about. But like the pictures, I can get the sentiments. So I took 2 different reviews, one old one, original one from the New York Times, and a recent one that is negative from Goodreads. The one from the New York Times is pretty positive. Okay, and so the API tells me for each sentence the level of sentiment between -1 and +1. So, and it works for here, the 3 negative ones, they come from Pauline's review. She didn't like the book. And the positive ones come from the New York Times. So, like the pictures, you can know whether the text is talking positively or not as a whole or at the sentence level. Okay. And likewise, you can classify content. So if I give the same sentence, it's going to tell me, okay, you can classify that in books and literature, and I am 97% sure of it, and which is correct. Okay. So likewise, if you want to use that with your favorite language, it's pretty easy. You create a client, you provide the data, and you call the feature analyze sentiment. So just a few lines to get the result. Example, Ocado is a British company. So it's a retailer in the UK. And they've been using that to improve the efficiency of their customer service. So basically, they communicate about it, so you can check on the web if you're interested. For instance, they process the customer emails, and when there's something negative, they treat that in priority, so they are more efficient. Okay. Now, still on text, the translation API. So I won't enter into details. I bet you have all used it somehow. That's Google Translate, right? So it works from over 100 to 100 different languages, thousands of combinations. And you can even input HTML. So for instance, you can input an email in HTML, and you will get the translation. You've seen that in your browser. It's translated live. And one thing I noticed a couple of years ago, I wasn't working for Google. I was just a simple user. I noticed that the quality of the translation, especially with French, improved from one day to another. It was quite brisk. I don't know if in German you noticed that roughly 3 years ago. And I got the explanation. At Google, they switch from a statistical model to a machine learning model, and that's where the quality came. Okay, and just keeps improving because the model is being trained continuously. Okay, so still an example. So here you just need you need 3 lines basically. You need to import the package, you create the client, and you call translate. Okay, example, Airbnb, they're using that. 60% of their users don't speak the same language. So it's pretty hard, to do the connection. So they translate virtually everything. Okay, live demo. Text me, okay. So what I did, I built upon the existing demo, and I added these 2 layers. So you're going to be able to send me text, okay, with your smartphones. I will work in English. I could do it in German, in French, anything. If the text you send me, so use German, use your native language if you're not German, or any foreign language that you learn. If it's not English, then I will translate everything into English, and then I will put the natural language analysis over it, and let's try to see what you have to tell me, okay? So I go back to my demo, and yeah, so let's show you, go back to step 1. Let's show you with a few examples that are pre-typed. Okay, so I have some English, some French, some Spanish, Chinese, and Japanese. And here is how it's treated. Okay, so everything is translated to English, so you know what it means now. Here are the entities. So I've been talking about raspberries, watermelons. And here are the sentiments. Yeah, I love raspberries, but I hate watermelons. So you can see that here. Okay, so I clear the data, and now it's up to you. You can you can go to the next step or refresh, and you can tell me anything. Please respect the code of conduct. Be kind. But you can be negative, okay? But still kind. I'm gonna say something in French, okay? Okay. In French, yeah. Okay. So I don't see you typing, yeah? Tell me something. Okay, so let's see how many feedback we got. Yeah. So some German. Someone tried, yeah. I took care. Actually, I got fooled. In my first demo, I got fooled. Yeah, I got hacked, but yeah, it doesn't work anymore. So German, Russian. No, that's not Russian, is it? So this is Russian. Okay, so Ukrainian. Okay, interesting. German, GL. Galician, yeah. Russian, German, Arabic, German, Russian, German. Okay, so you've sent me something. So now let's see what you've been talking about. Hamburg. So I have, the 3 of us have talked about Hamburg. Someone about Mars, mustache, France. Yeah, France. Who? France, okay, I don't know what it is, but I could just click here. France, Brötchen. France, Brötchen. Okay, Hamburg script. Okay. So, yeah, 12 persons. And here are the sentiments. Oh, thank you. That's nice. I love skateboarding. Yeah, I love. Cool presentation. Everything works really well. Yeah, I'm lucky. So this one didn't get translated. Or, very simple test. Okay, mustache, good for you. My first time. Okay, that's what I told you in French. It's everything positive. So here is the neutral parts. Do you need a French cheese from the moon? Yeah, yeah. You must love. And the negative ones. I do not like the Jungle Book. The weather in the box is not that bad. I hate watermelons. Okay, so you see it works pretty well, and that's very easy to implement. So now let's go to two APIs working with speech. The first one, speech to text. So like the translation, it works with a lot of different languages and variants. So you know the different accents that you can have. For French, it would be French-French, French-Canadian. It's real time, so that's quite a challenge. Being able to convert speech to text in real time. It's robust to noise, so the neural networks, the neural network models have been trained to eliminate noise. And also, like everything else you saw, it means you can index your speech. So you can know exactly where each word is located in your audio stream. Okay. As an example, like Airbnb, Azar that's a matchmaking app. So they are connecting people from all over the world. They're translating all the text, but they're also using speech to text to continue translating everything. So you can actually talk to someone whom language you don't know. Okay. So let's try it. I didn't have the time to do something proper in my demo, but actually there's something here that just works. What is the temperature in Hamburg? So you see it works. Despite my accent. And the funny thing is that when I started to pronounce Hamburg, I don't know if you saw that, but it thought it was Hong Kong, and then it corrected Hamburg. So despite my accent, it understood what I said. And those are all the building blocks, you know, for assistance, for instance, a chatbot, a Google Home, an Alexa device. You can talk to an assistant which is going to understand you and give you back an answer. Okay. And now the opposite, text-to-speech. So this is not new. This is new at Google. So it's a few months now. It was announced at the beginning of the year, but it has been there for a long, long time. For instance, in 1999, I did integrate text-to-speech in the first ebook device I made. So it worked. Technically, it worked. It could read the book aloud. All the words were synchronized, so you could say, OK, read me the book. Everything worked. I was very proud, but nobody used it because it was like a robot talking to you, right? It was unbearable. And as of today, with machine learning, we reach a new level. This is really like a human voice. And maybe this is the most advanced technology here. I told you the Vision API is my favorite, but here with WaveNet technology, we are reaching really the human level. It's pretty amazing. So it has been developed by DeepMind. Maybe you know them because they beat the world champion for Go. So there are papers, if you're interested, have a look at that. It can generate 20 seconds of speech in only 1 second. So that was also another challenge. And it works great. And let me show you or get you to hear these samples. So there are 2 samples. Oops.
She earned a doctorate in sociology at Columbia University.
OK. And the second one.
She earned a doctorate in sociology at Columbia University.
Are you able to make the difference? No. So with my teammates, we've been playing a game. We have many samples like that internally. And we try to guess, OK, this is the original one, and this is the one generated by WaveNet. But we were wrong half of the time. So we are at a level here where we're able to hear something that we can't tell whether it's machine generated or not. Maybe you've heard about duplex. So soon machines will be able to call a restaurant and book a table for you. And of course, it's a bit creepy, I would say, but we're going to say first, which we didn't do initially, we're going to say first, hey, hello, I'm the assistant for Mr. Picard. I would like to book a table for him. Okay? And also, for instance, we're going to call the shops for bank holidays to make sure whether they're open or not. So sometimes it's not clear on the web, right? So it can be something that is going to change, improve the way we work. Okay. The second thing is AutoML. So with AutoML, so what we've seen so far are existing machine learning models, right, that you can use. With AutoML, what you can do is provide your own data to get one of these models customized for you. And what it does, so you provide your data, you launch a training, it's automated, you don't have to do anything. You check the results, of course, so maybe you will have to do that a few times. And when you're happy with it, you can deploy and serve, and you have an API exactly like what we used before. You have an API with your own model, your own API, your own data, just for you. Okay, as of today, it works. So this is pretty new. It's also from the beginning of the year. It works with Vision, AutoML Vision, with natural language and with translation. So you provide image or text, and then you get custom classifications or custom translation. Okay, an example. So if we use the Vision API and if we give 2 different pictures of the sky, it's going to tell me, okay, it's about a sky, a cloud. I have the same results with the 2 different pictures. But the pictures are very different. If I want to recognize different kinds of clouds, the Vision API today is not able to tell me. So with AutoML, you can actually customize the Vision API for you. And the way it works, you give your own data. So you give labels for that. So samples of altocumuluses, and so on. So here there are 5 labels: Sirius, Cumulonimbus, and so on. Then you launch the training, you evaluate the result. So here is a training that was just done in 1 hour, and the precision is around 85%. 1 hour is free, but it's for you to be able to evaluate the result. So it was okay, only, let's say, a couple of 100 pictures per label. And then when we were happy, that's Sarah Robinson, a teammate of mine. She did this demo. She's amazing if you want to follow her. And then she launched the same training for 3 hours, and she reached 92%. Okay, so it means it's able to get 92% of true positive and of true negatives. There are 2 other cases, the false positives and the false negatives. Okay, just to give you an example, we provide this tool for you to understand where it's working well and where it's not working well. So the diagonal here is where we're able, we're perfectly able to recognize cumulonimbuses, right? But here we're pretty bad. Oops, go away. The altostratus, we don't manage to recognize it. So it means that our input data is not that right. Either we don't have enough quantity, either we don't have enough, or we don't have enough quality. So then you can have a look at your data and say, oh, okay, I have 100 pictures, they all look like the same, so I should use different types of pictures for the altostratus. Or maybe I just have 100. That's not enough. Let's use 200 or 300s, okay? And then when you're done, you have an API like this one, and this is a picture I took. It was not here. It was in Poland. And it's able to tell me, yeah, this is a cumulus, and I'm 98% sure about it. Okay. So quickly, how does it work? There are 3 techniques below that. The first one is transfer learning. So what it does, it uses the existing model, and it produces new layers. And the new layers will customize the model for you with your data. Okay, so that is something that is known by the machine learning experts. Something pretty new at Google, and I think we're the first ones to do it, I think. Machine learning for machine learning, or internally we call that meta machine learning, meta learning. We are actually exploring different types of neural network architectures a lot and choosing the best one before the training. So we are actually doing trainings before doing the actual training. So there's a paper about it. If you want to have a look, you can use the link at the bottom. And the last technique is known to the experts. When you have a model, you have different static settings, right, that you can change. Humans, experts, know how to tweak them to get better results. But now with machine learning, we can do better than us humans. The machine learning is able to optimize the hyperparameters for us better than we can. And thanks to these three techniques, we can get custom APIs without being a data scientist at all. So there are 3 companies already using AutoML solutions. Disney, they're trying to recognize their characters everywhere in pictures. And one cool example, I was in London last week. I talked to the company which worked with the Zoological Society of London on the right. And they've been doing something amazing. So for years, they are taking pictures in the different forests all around the world. They are taking pictures whenever there's a movement, and they are trying to recognize the different species. And you don't just want to know it's a monkey, you want to know which kind of monkey it is. So they have tons of data, right, that they already humanly labeled. And now with the custom vision API, they have their own model. They are going to open source it for all the other organizations in the world to use it. So it means you input a picture and you will know which species it is. Okay, something that only this organization could do, because it would take a lot of time to label such pictures. Okay. So the last more machine learning. I won't talk about it, just mention it. If you're a data scientist, or if you want to do more machine learning by yourself, you can use existing tools. One of them is TensorFlow. That's an open source library. It's the preferred, it's the #1 machine learning project on GitHub. It's in Python. Now it's available in JavaScript. And with that, you can build your own neural networks. Everything is packaged. It helps you. And also, it could take days or weeks to train something on my laptop, even though it's quite powerful, even though it's using GPUs and so on. So you can also now do the training in the cloud and go from days to hours, okay? And then everything is in the cloud and works. Okay, so it's time to wrap up. I will publish the slides, but if you want to get some pointers, here they are. I hope you learn quite a few things today, but more importantly, I hope it gave you a few ideas. That's it for me. Thank you. And if you have some questions, I'm here now and around if you want to catch up with me later. Do you have questions? Yeah?
Please go back one slide.
Yeah.
Thank you.
Okay. So that's for the pointers. Any more detailed question? Okay. So I'm going to take a picture. That's a big room. I've never done a selfie with an audience. Yeah, I even don't know how to do it, right? Yeah, so say hi. Hey! Thank you. So have fun. I hope to hear about you doing some machine learning cool stuff. You've seen all the different principles. Thank you.